everyone here, this is Eason Lee from Think Academy Singapore. Today, we are going to talk about the special question. It's called indeterminate word problems. Now, a word problems, usually we can have a certain value of answer using either model or algorithm. But in some cases, actually such a case happens once a year in NMOS Round 1 test, that we cannot get an accurate answers, or we can get many answers that may fit the situation. But we need to choose maybe the smallest one or the largest one from it. And that is called the indeterminate word problems. This question has a specific point that we cannot use the algorithm to find the actual answer, as the algorithm may be not able to solve. Instead, we should analyze the relationship between amounts and use some maybe the number theory part that each amount in the question should be integers, and use such things to help us find what the answer is. So this question, of course, is difficult as it's abnormal and may include maybe the number theory, other point of acknowledgement. So it's a complex question and it's always worth 3 points. So let's look it out. The first question is 2017. Yeah, it's a 3-point question. First of it. It says that in a class, 30% of the girls wear glasses, and among the wearing glasses students, 60% are boys. So find the smallest possible value of students in class. This class has even number of students is important here. Okay? So in this case, we can notice that students can be classified in 2 ways. First is the sex, right? Male or female. Then we can classify it by wearing glasses or not. So if we have 2 ways to classify people, classify the amount, we can use listing to help us. For example, we can have boys and girls. We can have wearing glasses or not. But when we use a list, a table, to do this, we should not forget the total. Okay? In every table need a total here. So it says that 30% of the girl wears glasses. So we can maybe just let the total girls be 10 units, and wearing 3 units, not wearing 7 units. Then among the wearing glasses, 6% are boys. So wearing glasses may be 60% is 3/5, right? So 5 units, 3 units, and 2 units. Now, by the table, we can easily find that one amount is represented by 2 different units. That is the girl who wears glasses. In red is 3, in blue is 2, and as I mentioned before, a same amount should always use the same unit. So 3 and 2, we can turn it into 6, right? So now, we turn it into 6. Which means, blue will be time 3, and here will be time. Right. So now we unify the unit, and we see that the boy and girl wearing glasses is 9 to 6, and the girl wearing glasses not wearing glasses is 6 to 14. Now what we should know that the smallest possible total number of students. So there are 2 ways for the answer to be the smallest. First of all, the black number here represents the unit, right? This is not a single number, it's a time of unit. So to be the smallest, we let the unit be 1. So 9 units means 9 people. So this is the smallest for this 3, right? And then we have another amount that has not been determined. That's the boy who does not wear glasses, right? So here can be any number as we like. It can, for the smallest one, it can be 0. But if it's 0, right, here is 9 and the total number will be 29. It's an odd number. So to make it become an even number, maybe we can add it by 1. So the second step, for the birds do not wear be 1. So now is 10, 20, and 30. So the smallest possible number is 30. Now this is a typical question of the indeterminate word problems. So we can find the ratio of some amounts, but we cannot determine the unit. So maybe we should let the unit be 1 to be the smallest. And if there is another one undetermined, we can make it as small as possible, maybe 1 in this case. Okay, so this is the 2017 problems. Now, the second question comes from the 2022, right? It's the last question of the year, for question 30, right? Question 30, is it the most difficult one? I don't think so, by the way, but it's difficult, I had to admit. So here comes that Tom and Peter take part in a test. They have questions, both of them answer questions, and some questions Tom get correct, sometimes questions Peter get correct, some they both get correct, and some they both get wrong, right? So this case is a very important argument of the include and exclude questions. So in that case, we always draw a Venn diagram, if that's a name. So here is Tom, here's Peter, and then now let's see. Tom answered 3/4 of the question correctly. Peter answered 5 questions wrongly. And the question both of them get correct, there is the middle part. It's more than half the total number of questions. And the question they both answer wrongly is 1/5 of the questions. So how can we calculate it? In these questions, we know only a few amounts. So the most valuable things come from these 2 fractions. See, Tom answered 3/4 of the question correctly. So the total number should be a multiplier of 4, right? Or the amount of questions should be an integer. Also, we notice that the question they both answered wrongly is 1/6. So which means the total number should also be a multiplier of 6. That's what I mentioned before, that sometimes we should use the integer. Just everything in this question, every amount in this question should be integers. So we can have the total number of questions be a common multiplier of 4 and 6. As the LCM of it is 12. So maybe we can name it to be 12u, where u is an integer as well. Okay, then we can move through. Just Tom answered 3/4 of the question correctly, so the circle of Tom has a worth of 9u here. And the Peter answered wrongly is only 5 questions. There is an interesting we should mention that Peter answered 5 questions wrongly, and together they have 1/6 of 12u's, which means 2u. Just both wrong is 2u here. We should know that a question they both get wrong should not be larger than the question Peter get wrong, right? It's included by this 5 question. So 2u is no greater than 5, which means the integer u can only be 1 or 2. So this is a breakthrough point. Now we can just maybe use the 1 and 2 in 2 conditions to calculate the include exclude problems and see if the answer fits the condition that they both get correct is more than half. Okay? So first, if u equals to 1, let's see. Then the question they both get wrongly, which is represented at the blank of the rectangle, should be 2 here. Then the question Peter get wrong will be 3. We can write 3 here, as this is the question that Peter get wrong, but maybe Tom get correct. Also, Tom answered 9U, which is 9, right? 9 correct. So the common question they all get correct is just 6. But we all know that the question both is more than half. In this case, it's just the half. So does it fit the condition, fit the requirement? Nope, right? So if U equals to 1, that both correct, can calculate as 6 and not fit. So U can only be 2. Again, if U is 2, the question they both get wrong will be 4, and the question Tom get wrong alone will be 1. And as Tom answered, this is 24 plus, it's 18, right? It's 18, it's 9U, it's 18. So the total question Tom get correct is 18. The common question should be 17. So this is the answer we need. So in this case, it's an include-exclude problem, which you can always find this type of question in 2021 and 2019, right? They both share the same time. That in an include-exclude case, we find the extreme value of answer is an indeterminate answer. So we should know that as every amount here is an integer, we can define the total number and use the inequality to help us solve the problem. So it's very difficult, but if you have the ability, or maybe just you are brave enough to think about it, maybe you can get these 3 points other people can't. Okay, now that's all for today. Still, do not forget our seminar in the weekend. See you tomorrow and see you at the seminar.